The last thing we're going to learn is the test for homogeneity of proportions, and this is the test that's used to test claims that different populations have the same proportion of subjects who have a certain attitude or characteristic. So the process for this is going to be the exact same as what we just learned in the first video as far as like the calculator and putting things in matrices and whatnot. The only thing that's going to change is how we set up our hypotheses. So when you're doing this test, the null hypothesis is always going to be a statement of equality. So you're always just going to let the proportions that you're referencing in the question be equal to each other. And it just depends on how many there are. So if there's 3 of them in the question, then you're going to put that P1 equals P2 equals P3. If there's 5, you'll do P1 equals P2 all the way up to P5. And then the alternative hypothesis is just going to be this statement here. So this won't change. You're always going to say that at least one proportion differs from the others. And then either one can be your claim, just depends on the question. So example 3 says that according to a recent survey, 64% of Americans between the ages of 6 and 17 years cannot pass a basic fitness test. A physical education instructor wishes to determine if the percentages of such students in different schools in his school district are the same. So he administers a basic fitness test to 120 randomly selected students in each of the 4 schools. Alpha is 0.05. Tests the claim that the proportions who pass the test are equal. So your keywords for this type of test is just simply talking about proportions. So this is the only time in chapters 10 and 11 that we're referencing proportions. So if you see that in the question, then you know you're supposed to do this process. Okay, so your hypotheses, let's do step 1. So for H naught, since we're talking about 4 schools, we're talking about 4 proportions. So we're just going to say that P1 equals P2 equals P3 equals P4. And then for the alternative, it's going to be that statement that we just wrote. So we're going to say that at least one proportion differs from the others. And then let's see. So for this question, the claim is that the proportions are equal. So I'm going to state that H naught is the claim. And then for step 2, we want to get our p-value, and this is going to be done the exact same way that we just did the chi-square test for independence. So remember, you want to cross out your totals if they do give you any. That's because we don't need to put those in our calculator. I'll do this one more time with you guys as far as the matrix and the calculator, but it's the exact same thing that we just did. So you're going to do second and then the x to the negative 1. Go over to edit, press enter. This is a 2 by 4 matrix. So do that, let it generate the new one, and then you just have to fill in all of those new values. And then once you have that done, you're going to go to Stat, go over to Tests, and then go to chi-square test. And click Calculate. And we just want to get the p-value from this. So it looks like the p-value is 0.1500. And then we'll compare that with alpha for step 3. So since 0.1500 is greater than 0.05, we do not reject the null hypothesis, which means for our summary statement, we'll say that there is not enough evidence to reject the claim that the proportions are equal. Okay, so I'll get us started with this last example here, but I will have you guys tell me the p-value for this one. So it says a local college recently made the news by offering foreign language speaking dorm rooms to its students. When questioned at another school, 50 randomly selected students from each class responded as shown, alpha's 0.05. Is there sufficient evidence to conclude that the proportions of students favoring foreign language speaking dorms are not the same for each class? Okay, so we're talking about proportions, so we know we want to do the test for homogeneity of proportions. So our null hypothesis, let's see, we have freshmen, sophomores, juniors, and seniors, so there's 4 different subjects, so that's 4 proportions. So I'm going to set P1 equal to P2 equal to P3 equal to P4. And then the alternative will say that at least one proportion differs from the others. And then if we read the question again, we're seeing if we can conclude that the proportions are not the same for each class. So that would correlate with the alternative hypothesis. So we'll label that one as the claim. And then step 2, to get the p-value, I'm going to let you tell me what that is. There's nothing different about this one. It's still a 2x4, so go to a matrix in your calculator, put in those new numbers, and then go to the tests and get the chi-square test and get the p-value from that. And then once you have the p-value, you'll see that it comes out to be greater than 0.05. So we do not reject the null. And then our very last summary statement of the entire semester will say that there is not enough evidence to support the claim that the proportions differ. So great job, you guys.